our statistics textbooks comes with a number of data sets that you are available in a file. They're available actually in an archive file. I'm going to show you in this video how to pull data out of that archive and then read it into Octave or MATLAB and then use it. And then I also want to show you how to create a Octave or MATLAB script file so that you're not always typing in all these commands at the Octave or MATLAB prompt. To get the archive that contains all the data sets in the textbook, first go to my home page, which is on csserver.evansville.edu / and then the tilde character. On most keyboards, this is just the character right below the escape key, tilde Richardson. There you'll see links to the courses I'm teaching this semester. Click on the Engineering 390 link. Okay, I'm still a couple days before the start of the semester. I'm in the process of adding content to this page, but so it may look a little different when you browse to this page. But if you scroll down, you should see a link to the textbook data set. Also notice right below that there's a line here, which is the line we'll use to read from a file in the archive into to create a MATLAB or Octave matrix. So, but right now you want to download this dataset archive. So just left click on it. You should see a page like this appear. Click on the download button. What I suggest you do is actually create an Engineering 390 directory or folder to keep all of your files and projects for this semester. So I just created an ENGR 390 folder, and I'm going to save the data set directly to that folder. It should only take a second. It's relatively small. And then at this point now I'm going to actually well, what we'll do is I'll go there first in the File Explorer. So go to that same ENGR 390 directory. And then this is an archive file, but with most operating systems, the various file managers will allow you to browse directly into the archive, so you don't really need to extract the entire archive. You can if you want, but I'm not going to do that. So just left click to enter the archive. There's a subdirectory, subfolder here called ASCII-comma, and then it's grouped by different chapters. I'm going to pull a file out of the archive that will just pull the first file here out of chapter 4. It's ex04-88.txt. The notation here on the file names, the EX stands for the exercises that are in the at the ends of each of the chapters. So this would be exercise 88 at the end of chapter 4, the corresponding data set. The EXP files correspond to the examples that are in that chapter. So I'm just going to right click and select copy and then go back up to my Engineering 390 directory. I like to keep my stuff pretty well organized, so I'm going to actually create a projects folder here, and then under projects create, I'll just call it chapter 4, and then paste that text file right there. This is a standard text file, so you can open it up in a text editor. I'll open it up and we'll take a look at it once we start Octave, which I think is the next step. So let me start up Octave here. And then now I want to browse to that same and there it is, ENGR 390. Browse to that same folder where I copied the text file. Here I can right click on it and say open it up in a text editor and actually look at it. The first line contains labels. This particular file has 2 columns worth of data. data. The data in each row is separated by a comma. The terminology is it's a comma delimited file, or a comma. The values are comma separated. So that's why the archive was called, had a CSV in the archive name. This is comma separated values. We'll need to skip over the first row since that contains just text data or strings, and then read in the data from the remaining rows. So it goes, there are 16 lines of data, the first line being labeled, so we should have 15 rows of data after we read it in. Okay, so I'm going to click on the command window tab. The easiest way I found to read in this data with either Octave or MATLAB is to use the DLM read function. DLM is for reading delimited data. DLM stands for delimited. The first argument is the file name that needs to be passed as a string. So ex04-88.text. The second argument, so comma, and then we're going to put another comma within single quotes to indicate that the values within the file are actually comma delimited or separated by commas. We need a third argument. This is the number of rows we want to skip. We want to skip the first row, followed by the number of columns we want to skip. We don't want to skip any columns. So we'll read all of this into, I'm reading it into a matrix that I'm assigning the variable x. So just hit enter and it'll display all the data in the file. Again, X now consists of, should have the 15 rows and then the 2 columns containing all of the data. And I could go back and look at it in the text editor to verify that this is correct. And then now I can do things like create a histogram. The histogram function expects an array, so a row or a matrix of only one column. But I can pull out, say, that the first column, a colon represents all rows, and then this would be the first column. So I can create a histogram of the data in the first column that appeared somewhere else on the monitor. So that looks like that. Or a histogram of the data in the second column. That looks like this. That's a little more interesting. Okay. Instead of entering these commands by hand, it's a lot more convenient to actually create a script file. In MATLAB Octave terminology, they're called M files because they have a .m extension. So I go up here to the little, in my file browser in Octave, I go up to this little cog and say new file, and then I'm going to call the new file ex04_88.m. I'm using underscore in my file names here for my M files instead of dashes because MATLAB and Octave will interpret a dash as a minus sign and actually try to do arithmetic on the file name, and I don't want that, so don't use dashes in your M file names. It's okay to use a dash in the text file name here, and then click OK. So what I've done is actually just created an empty file. I can double click on it, double left click on it to open that up in the editor. And then here's where now I would actually type in any commands, just any commands that I might type at the command line. But the advantage is I can come back and edit the script, add new commands, and then just rerun the script. I don't have to retype in all the commands. So again, here I want to read in that text file, comma, quote, comma, quote, comma, skip the first row, skip none of the columns. I'm going to end the line here with a semicolon so it won't actually print out the data. And then again, I'm going to do a histogram now of the second column. I'll put a semicolon there. And then I can just run this directly from the editor by clicking on this little cog that has the triangle in it. It will automatically save the file. The little asterisk here means that the file has not been yet saved. The contents of the editor have not yet been saved to the file. So I can do that by clicking on the little save icon, but actually the triangle here will automatically save the contents and then run it and produce the histogram. The advantage of this, of putting the stuff in the file like this, is now I can add additional content, figure 4-88 to put on a title. I can add an X label. I forget what the data in the file actually is. I'm just going to call it data values, which is not a good label. And then just run it again, and it carries out all these commands again. It's going to read the data again from the file, create the new histogram. But now I've been able to add title to the plot, as well as a label to the x-axis. So I could continue to edit this particular script until I got the plot to look exactly like I wanted it to. Then I can just close the editor by clicking on the little X here. A couple other ways to run M files. Back at the command window, I can just type ex04_88 to run it directly from the command prompt. Leave off the .m extension on the file. It's got to be in your current working directory. So that's one way to run it. Another way is from the File Explorer. I can just right click and say run, and then that will also run the M file and create the plot for me. A couple other things that you may want to do here, that some useful commands. If I want to get help on the histogram function, for example, I can do help hist and see a bunch of additional information. I have to scroll up here to see. I'm using hist in its simplest form, just passing it a column of data. And there are a number of variants. It says by default it produces a histogram with 10 bins. You can see if I want to produce it with 20 bins, I just have to pass it a second argument. So I can do that, comma 20 bins, again rerun it, and now I get more bins and a different looking histogram than I had previously with the default value of 10 bins for the data. So that's useful to be able to look at the help. Again, I can also look at help for DLM read if you want to explore all the different options that we used there. If you prefer browser type help, I can just use .hist, and it'll take me over to the documentation tab, and it'll do a search for the hist function. And so here I can read, kind of a browser type description of the hist function. I think it's actually the same content that you can see from the help command. This takes me to the section in the user manual that documents the hist function, and I can scroll up and I see that that's actually in a section of the user manual that describes two-dimensional plots. You see there's some tabs up here at the top with regard to documentation that I can expand these, look at, for example, expand the getting started, look at invoking Octave from the command line options, actually. Let me look at something a little more interesting, built-in data types. It talks about the different types of data that we can use that are available in Octave. So, but anyway, you can just go directly to the documentation by clicking on the documentation tab. I think that's all I wanted to show you in this video. I know it's been a little long. Thanks for bearing with me, but this should help get you started on various projects that we have assigned in the probability and statistics portion of the course, where you'll be asked to read data from one of the available data sets and then process it using MATLAB or Octave.